I've been busy trying to figure out how to get that 3D printer running, my Fortus 400mc, and discovered some interesting things. Welcome to 3D Accuracy, where I'll talk about 3D printing, 3D product design, and 3D injection and die-cast mold design. I have a block diagram of the electronics in the 3D printer, and look what I found. Here is the main PC board, the one on the top that had the connections A, B, and C that we've been checking to verify voltages. You can see here is the main circuit breaker. Here is the three-phase input power coming from the three-phase converter going through the transformer, and the main 20 amp circuit breaker. Okay, and you can see those go to A, B, and C, directly to A, B, and C. Now there's this jumper here, this jumper 3. And on this jumper 3 is a connection for the UPS switch. The UPS is the backup battery, this fella down here. And that switch turns on the electricity that goes to the battery, turns the battery on. Now, this is what caught my attention, is the 10 amp breaker. And I'm like, 10 amp breaker? I didn't know there was a 10 amp breaker in there. What the heck is that? So let's go out in the shop and find this 10 amp breaker. I want to know what this thing is. All right, let's get the treble light. Okay, here's the area we're talking about. Right back here where we've been many times in the last several videos. You see, here's our 20 amp breaker, the one that turns the machine on, is right here. That's this guy. This is the switch that activates the battery, sends electricity to the battery so it works. So I got tracing the wires from this jumper up here. You see this little jumper on the PC board right next to all the connections, the A, B, and C where the electricity comes in. And I traced the line. You can see the lines and the wires. And it comes right down into the top of here where this battery is. And there, that little white box that has green lettering on it that says Schneider on top is the 10 amp breaker. It's the same as, you see the 20 amp breaker right here, that's a Schneider also. Okay, it says so right on the breaker. Now, you notice the difference between this breaker and this breaker is that this breaker does not have a throw lever to reset it. That's this fella here. It has 3 wires and it's a single throw with 3 lines in it. Okay, turn that on and off. This one doesn't have that. What this one is a self-resetting circuit breaker. In other words, when it blows and you turn the electricity off, the breaker resets itself and becomes useful again. You know what else that breaker does? When it trips, it makes a boom, makes a pop. That's what made the pop when I had the printer on that one time and I didn't know what it was, where it was coming from. It was that breaker. And the reason I know that it does that is because this printer over here, my Eden 333, has the same type of breaker in it. And when the electricity is not right, it makes a pop, boom, and it automatically resets itself. And I asked Stratasys about that the first time it made the pop. I said, does it have one of those same breakers in? And they didn't know. They weren't sure whether it did or not. Well, they have since learned, and I have since learned, that it definitely has one of those breakers. That's what's in there. So now I know what the pop was. It's a good pop. It keeps the machine from getting damaged. That's the kind of pop you want to hear when you have an electric problem with one of these printers. So if anybody ever experiences that, it makes a pop, there's something wrong with the electric, but that circuit breaker is going to protect the system from causing any damage. So that was a big sigh of relief, because now I know what the pop was. Okay, so let me show you what else I found out. So what else I found out is I went to the backup battery, and you see here's the power input on the UPS backup battery, 230 volts AC. It is not three-phase power. It is single-phase power to the battery. This is not a three-phase battery. But we follow this line. We follow this line up here. Where's it going? It's going right to jumper 3, right to connector 3 on the PC board. Now, I looked at the wiring, and A and B run to this connection on the circuit board. You can't see it here in the wiring diagram, in this little block diagram, but on the printed circuit board itself, that's where it's coming from, is A and B. Now, that's a good reason why I changed that connector in the back of the 3D printer where the three-phase comes in, and I put the black wire on L1 and the white wire on L3, because I want that white wire, the manufactured line, to be on terminal C. I don't want it to be on A or B, because these things, the battery, and by the battery, it also includes the computer, because you see the output line here runs up, runs over to this guy, runs up to jumper 12, connector 12, which goes back and it runs input to the power supply on the computer. This is also 230 volts, single phase, not three phase. That's why I wanted to make sure that manufactured line, I didn't want it to be feeding the battery or the computer, because the 230 volts coming from the line that goes directly from the sub panel are clean lines. The manufactured line that comes from the three-phase converter motor is the one that's high. Now, line C, connector C, which is the manufactured line, it appears to feed these connectors. Oops, what did I do here? What's going on? I bumped something with my elbow. Anyway, the line that feeds these jumpers here include the C terminal from the manufactured line. These go to the heating elements in the machine that heat up the build chamber. Heaters need to get so hot when you're printing the high temperature materials such as polyphenol sulfone and Ultem. The build chamber needs to get very hot in order to print those. So I would rather have that line that's a little hot, little too much voltage, the manufactured line, feeding the electricity to the heating elements. So you can see it goes heater element 1, 2, and 3, or 2, 3, and 2, 1, and 3. Okay, I would rather have it feeding those, because the extra electricity is not going to really cause a lot of damage, I don't think. It's just going to make them run a little hot. And once they're up and creating a draw on the system, it's going to balance that electricity back out according to what the folks at American Rotary tell me. So, solve two problems. Make sure I have the manufactured line feeding the heating elements, not the backup battery, not the computer, and finding out about this 10 amp breaker So now I know what the pop was, and I know that it's nothing that has caused any damage. Now, the other thing, there was the transformer in the back of the 3D printer, or the little power supply that supplies the 24 and 48 volts. Everything there is clean. I checked all the connectors. Everything works right in the safety system that regulates whether the machine will turn itself on or not. So I'm assuming that little transformer is working properly because I checked the 24 and 48 volts. So the next thing is the battery. Now, let me tell you the story about the battery. I've determined that the battery is going to go. I want that out of there. So here's what I've done so far. As far as I can tell, this battery is no good, or at least in need of some repairs, and I'm going to replace it. So what I've done is I actually ordered another battery, one that sits outside the printer. And I purchased it. The only place I could find one was on Newegg. So I ordered one. It came, and it was priced online as a new battery. And it didn't say whether it was a new battery or an old battery. It just was the battery that I need. And so when it got here, you could tell it was used or at minimal returned. It was packaged poorly. The battery was loose in the box. It bounced around, cracked the front panel. I sent it back. I purchased another one, which I found online on eBay, a used battery, and it just came yesterday. Box is right there. Now, let me show you the battery. I have it sitting over here on my desk. Here's the battery. This one will sit outside the 3D printer. And you see it has, I got to peel off the little label here, but here's the LCD screen. And so I'm going to put that on the floor alongside the air compressor, and I'll be able to easily see it and use it, okay? Because here's all the controls. Here's a little LCD screen. On the back side, it has all the outlets. I have to peel this sticker off, and it has, here's the inlet, 200 to 240 volts it'll take, okay? Here's all the cables. The one that came from Newegg didn't have any cables, didn't have the CDs, didn't have the manuals, didn't have anything except a kind of beat up battery that was obviously used and not good. So I have all the CDs, I have the manuals, I have all the cables. Now, this battery was listed as used. I believe it was listed as used not because it was used, but because of its age. It was made in 2019, but it does not show any indication that it has ever been used. It is absolutely no dust, no marks, no nothing. It looks like a brand new item that never sold. And so it was listed as used to get rid of it. Now, the only little drawback with this one is that there's stickers on the box. And this is the original box that it came in. You see there's these 1, 2, 3 stickers on there. They have numbers on them. And those numbers match the stickers that are on the unit itself. There's a sticker here in the back, and it has a number on it. Matches the one on the box. The back side of this panel has a sticker on it. Matches the one in the box. The face of the battery behind it here, let me pop this panel off and I'll show you. Okay, take that, see there's a little sticker in the back of the panel, matches on the box. This sticker here matches the number on the box. Okay? So it looks to me that this is a battery that's been sitting in the box for years and years, never been used, never been sold. Okay, I have to take that panel off anyway because I need to plug these two together before I can use it. Now, the only question I have is whether this battery, the batteries are still good, because there's also a little sticker on the box right there with the manufacture date. It was manufactured in July of 2019. But that little sticker also says recharge battery by some date in 2020, like a year later. So I'm sure it has never been charged since 2019. Whether the battery will still hold a charge or not, I don't know. You can replace those batteries. I can get new batteries to slip into the unit. So everything else should work. I may need to replace the little individual batteries that are in there. I think there are 3 or 4 little battery units that are inside of there. I'm not 100% sure. So what I'm going to do today is I'm going to hook this battery up to the machine. What I'm going to do is I'm just going to set it on the floor here. I don't need to have it in position. And what I also did is, you see the cable, the power cable here? I purchased some extension cables because I need to go from the cable inside right here, where you see where it's plugged in, and bring it outside to the battery. So I have 2 of these extension cords that have, well, here's the other one. See, they have regular computer type fitting on plug on one side, and then this little bit different one on the other side. There's C13 and C14 extension cords. I don't know which end is which. I don't care, as long as they work. So what I'm going to do is put the battery on the floor, plug it in to the power supply. Oh, and the other thing I did, before I get any farther, is I went ahead and turned the power on, turned everything on, turned on the printer, and I checked the voltage right here on this plug after I plugged in the extension cord. I'm getting 229 volts to the battery, which is perfect because we're targeting 230, so 229 is fine. I will take it. So I know the voltage is correct, 230 volts, AC, single phase. I'll put the battery there, and I'll see if I can get the battery charged up and if it will hold a charge. Then if it does hold a charge, then I will go ahead and connect the battery to the computer. And I also bought an extension cable for the Ethernet, the network connection that needs to connect the battery to the computer. So I'll connect that up and see if we can't get the machine running. So that's what I'm going to do today, is put the battery in line, see if I can get a charge on it. Battery's in place, and I removed the front panel, plugged it into itself so it'll work. Plug the power supply in on the back. That's coming from inside the machine. So let's go ahead and turn everything on and see if it'll take a charge. So let's start here. 3-phase. Okay, that's up and running. Turn on the circuit breaker. Now the transformer is working. I can feel it humming. I can feel it vibrating and hear it humming. Okay, now let's turn on the power supply, circuit breaker on, and then trip this little switch last, which supplies voltage to the battery. Aha! What do we have? Of course, I have to get down here on my hands and knees on the floor to see it, but it's still much easier than having it behind. Okay, English. I think we'll accept that. 230 volts. Output voltage. Okay, that's what we want, 230. Please register at blah, 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 blah. Yeah, I know I see that on the label too. Load not powered. Okay, it can't power it because it's not plugged into it. It has an 86% charge. That's good. Has an 80% sig charge. Okay, group 1 off, group 2 off. Okay, group 1 and group 2, what that is on the back of the battery. Let me show you. On the back of the battery here, behind this label, which I'll take off later, there's a series of output receptacles in there that where they plug in. You can plug in computers, you can plug in whatever you're using, and you can turn them on and off as groups, and that's all that is. So depending upon where I plug it in, I'll have to turn on that group. Alright, so what I want to do is just let this work for a while, see if it charges. Press that to start. Let's press this. Oh, not powered. Okay, 87%. Alright, it's already gone up 1%. So the battery is apparently taking a charge. So that looks good. That's very promising that it had 86% charge already on the battery, and it's already gone up from 86 to 87%. So that tells me it's charging. So I'll just let it sit, let it work, and then... I hope you really enjoyed this video. If you're ever in need of 3D product design, 3D injection mold design, 3D die-cast mold design, or 3D printed prototypes or production parts, please feel free to contact me. You can find contact information in the video description. I look forward to hearing from you and to being of service to you. Thank you for watching. As always, I appreciate it. See you on 3D Accuracy's next video.